Welcome to Two Projects. In this video, we are going to explain the project Cyberbullying Detection in Social Networks, a comparison between machine learning and transfer learning approaches. Introduction. This project delves into the critical issue of cyberbullying in online social networks, driven by the escalating misuse of information and communication technologies, that is ECT. The pervasiveness of cyberbullying necessitates automated detection for the safety of online communities. With the dark side of ICT being cyberbullying, there is an urgent need to shift from manual monitoring to automated detection. The sheer volume of online data makes manual filtering impractical, emphasizing the necessity for computational approaches. So, the primary objective is to employ state-of-the-art natural language processing, that is NLP, and conventional machine learning techniques to automate the detection of cyberbullying instances within online platform posts. This involves text classification, utilizing advanced features and models for robust detection. And the project aims to benefit online communities by providing timely and accurate detection of cyberbullying events. Beyond enhancing safety for users, the findings contribute valuable insights for social media platforms, encouraging improved mechanisms to combat cyberbullying and promote a healthier online environment. Objective of the project. So, as I mentioned earlier, the primary objective is to develop machine learning and transfer learning models for the automatic detection of cyberbullying in online posts, ensuring community safety by efficiently identifying and addressing potential threats. And the project aims to investigate novel features including advanced toxicity metrics and diverse embeddings, aiming to optimize the performance of the cyberbullying detection model. This involves selecting pertinent features contributing to the accurate identification and categorization of cyberbullying content. Another objective is to train and compare the efficacy of machine learning models like linear SVC, logistic regression, with cutting-edge transfer learning models like DistilBERT, DistilRoberta, and ElectraSmall. The aim is to identify the most accurate models for cyberbullying prediction, considering both established and advanced techniques. Additionally, the project aims to apply latent dirichlet allocation, that is LDA, for topic modeling, uncovering underlying themes within cyberbullying content. This secondary objective contributes to a comprehensive understanding by revealing prevalent topics and patterns in identified instances of cyberbullying. Requirements needed to execute this project are: software requirements. Software needed is Anaconda. Primary language used is Python. Front-end framework used is Flask. Back-end framework used is Jupyter Notebook. Database used is SQLite 3. And front-end technologies used are HTML, CSS, JavaScript, and Bootstrap 4. Hardware requirements needed are: operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Now we'll discuss the working modules of flow of work. So the first step is importing required packages. In this step, we import crucial Python libraries like sklearn, TensorFlow, Keras, NLTK, Seaborn, and Matplotlib. These libraries are essential for data analysis, natural language processing, machine learning, and visualization. The second step is exploring the dataset. So the cyberbullying dataset is loaded and explored to gain a deeper understanding of its structure, features, and distribution. This initial exploration provides insights into the characteristics of instances related to cyberbullying. The third step is visualization using Seaborn and Matplotlib. So here, Seaborn and Matplotlib are employed to create visualizations such as plots and charts, offering a graphical representation of the dataset. These visual insights aid in identifying patterns and understanding the distribution of different classes within the data. The next step is data processing. So here, the raw text data undergoes pre-processing steps including the removal of URLs, punctuation, and stop words. And text normalization, tokenization, and lemmatization are applied to transform the data into a standardized and analyzable format, culminating in the bag of words representation. And the next step is feature extraction. Here, vectorization techniques are used to numerically represent the pre-processed text data. This conversion enables the utilization of machine learning algorithms that require numerical input. The next step is feature selection. So relevant features are selected to enhance model performance in this step. This process involves choosing specific words and grams or other linguistic elements that contribute to the effectiveness of the models. The next step is splitting the data to train and test. So the pre-processed data is split into training and testing sets, facilitating the evaluation of model performance on unseen data. This division is crucial for assessing the generalization capabilities of the models. The next step is training and building the model. So here different machine learning models including linear support vector classifier, that is linear SVC, logistic regression, distal BERT, distal Roberta and Electra are trained using the prepared dataset. The models are subsequently evaluated and compared to determine their effectiveness. And in the next step, the project is extended by implementing a long short-term memory, that is LSTM model, renowned for its ability to process sequential data. Additionally, two hybrid models are created by combining predictions from multiple individual models, enhancing the overall accuracy and robustness of the final predictions. And a web-based user interface is developed using the Flask framework, and user authentication is implemented using SQLite, providing secure sign-up and sign-in functionality. After signing in, user input is accepted from the front-end and subjected to the same pre-processing steps used during data processing. This ensures that user-provided data is appropriately prepared for model predictions. And pre-trained models are employed to predict instances of cyberbullying based on the pre-processed user input. The predictions from the hybrid models are combined, contributing to a more accurate and robust final prediction. And latent dirichlet allocation, that is LDA, is applied for topic modeling, uncovering underlying themes within the cyberbullying content. This additional analysis provides valuable insights into the content and aids in understanding the nuances of the issue. And the final predictions and insights obtained from the models and topic modeling are presented on the web-based front-end. Users can interact with the system, observe the results, and gain a comprehensive understanding of the detected cyberbullying instances. Now we'll understand about the algorithms used. So the first algorithm built is linear SVC, that is linear support vector classifier. So it is a linear classification algorithm that works by finding a hyperplane in the feature space to separate different classes. It aims to maximize the margin between classes, making it effective for binary and multi-class classification tasks. In the context of cyberbullying detection, where the goal is to classify text data, linear SVC is known for its efficiency in creating clear separations between classes, making it suitable for identifying cyberbullying instances in textual content. The second algorithm built is logistic regression. So logistic regression, despite its name, is a linear model used for binary classification. It estimates the probability that a given instance belongs to a particular class by applying the logistic function to the linear combination of input features. Its simplicity and effectiveness make it suitable for binary classification tasks. And in cyberbullying detection, logistic regression can provide probability estimates, aiding in decision making by indicating the likelihood of a text being associated with cyberbullying. And the third algorithm built is distal BERT. So distal BERT is a lightweight version of the BERT, that is bidirectional encoder representations from transformers model. So it is known for its ability to understand contextual nuances in language. In cyberbullying detection, where context is crucial, distal BERT excels in capturing subtle linguistic cues. By leveraging a transformer-based architecture, it enhances the model's capability to identify cyberbullying instances by considering the intricate relationships between words in a sentence. And the next algorithm built is distal Roberta. So distal Roberta is a variant of transformer-based models specifically based on Roberta, that is robustly optimized BERT approach. It optimizes various aspects of BERT's architecture for improved performance. Similar to distal BERT, distal Roberta is well suited for understanding contextual information in text. Its optimizations lead to enhanced efficiency and performance in cyberbullying detection by capturing semantic relationships and nuanced patterns in textual content. And the last algorithm used is Electra. So Electra is a transformer-based model that introduces a novel pre-trained approach by replacing some tokens in the input text and training the model to distinguish between real and replaced tokens. With its efficient pre-training strategy, Electra can capture semantic relationships and subtle patterns in the text. This unique approach improves the model's ability to detect cyberbullying instances by learning from token replacements and understanding the intricacies of language in the context of online interactions. Now we'll see the comparison graphs. So this is the horizontal bar graph comparing accuracies of different algorithms. In this graph on x-axis I have accuracy scores and on y-axis I have algorithm names. So accuracy measures the overall correctness of predictions, showing the percentage of correctly classified instances. This is precision scores comparison graph. In this graph on x-axis I have precision scores and on y-axis I have algorithm names. So precision measures the accuracy of positive predictions, indicating how many predicted positives were actually correct. This is recall scores comparison graph. In this graph on x-axis I have recall scores and on y-axis I have algorithm names. So recall measures the ability to identify all relevant instances, showing how many actual positives were correctly predicted. And this is F scores comparison graph. In this graph on x-axis I have F scores and on y-axis I have algorithm names. So F-score combines precision and recall into a single metric, balancing accuracy and completeness in predictions. So the algorithm which is best performing in all the performance metrics will be used for predictions. Execution of the project. To execute this project, first we need to open the code folder which contains the project source code files. So this is cyberbullying comments dataset file, in which I have cyberbullying comments data with class label on which we will train the models. This is static folder which consists of files related to CSS, JavaScript and Bootstrap. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML pages. This is model file which contains algorithm information. This file will be loaded into the project code during runtime to utilize the trained model. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. And this is signup.db file. This file is the database file used to store user information. This is topic modeling Python file. And now copy the path of the code folder from the address bar of the file explorer. I'm copying it. Open Anaconda prompt. Use the command cd followed by a space and paste the copied path and hit the enter button. So this command is used to change the current directory to the code folder's path. Now compile the app.py file using the command python space app.py. I'm typing python space app.py and hit the enter button. So this command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address, localhost and port unless configured differently. Now copy the local link provided by the framework. I'm copying it and paste it into any web browser. I prefer Chrome. After pasting it, hit the enter button. So the home page of the project has been displayed in the browser. This is the front end built using Flask framework. So here we can see a sign up link, click on it. So if you are new users, we have to register first. Fill in these details and click on register button to sign up. And if we already have an account, we can directly log in by clicking on this link. So as I already have an account, I'm clicking on this link. So here we have to provide our credentials, username and password. And click on login button. So it has redirected us to the detection page. So here we can see a enter your message box where we have to enter a text for which the application will classify it as bullying or non-bullying content. So I have entered this message. Now click on predict button. So it will take some time to load. So here we can see the result. So this is the uploaded message, and here we can see the classification, that is non-cyberbullying content. Now click on home link. We'll try giving another message. So I have entered the message. Now click on predict button. So this is the entered message, and here we can see the classification, that is cyberbullying content. And here we can see the topic for the paragraph is most dependent upon. So based on these words, the entered message is classified as bullying content. Now click on home link. We'll try giving another message. I have entered the text. Now click on predict button. So this is the entered text, and for this text it has classified it as a cyberbullying content. And these are the words based upon which the message is classified as cyberbullying content. So similarly, we can give any text and can get the classification whether it is a cyberbullying content or not. Now click on sign out link. So the conclusion here is the project successfully addresses the pressing issue of cyberbullying by employing a diverse set of machine learning algorithms, including linear SVC, logistic regression, distal BERT, distal ROBERTA, and Electra. This ensures a robust approach to identify instances of cyberbullying in online content. And by leveraging advanced natural language processing techniques, the project incorporates features such as text normalization, tokenization, and bag of words representation. This enables a nuanced understanding of the language used in online posts, contributing to the accurate detection of cyberbullying. And the extension of the project involves the implementation of long short-term memory, that is LSTM, and hybrid models, combining predictions from multiple individual models. This innovative approach enhances the accuracy and reliability of cyberbullying predictions, providing a more robust final outcome. And the development of a front-end using the Flask framework ensures a user-friendly experience for individuals interacting with the system. Incorporating user authentication through SQLite adds an additional layer of security, creating a reliable platform for users to engage with the cyberbullying detection system. And by applying latent dirichlet allocation, that is LDA, for topic modeling, the project goes beyond simple classification, offering valuable insights into underlying themes in cyberbullying content. This contributes to a comprehensive understanding of the issue and provides additional context for addressing and preventing cyberbullying in online communities.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.